Welcome to physics class. So now in this physics class we'll just learn on simple pendulum. So here on this simple pendulum we have I'm just having these few notes that I've just come up with. So you can just pause the video and copy these few notes. So here we are saying that a simple pendulum consists of a bulb hanging at the end of a string or a thin wire. Now we also have terms associated to simple pendulum. When we talk of period, which is the time taken for a bulb to complete one oscillation or cycles. Oscillation is a complete swing of motion. Frequency is the number of complete oscillations per second. Then amplitude is the maximum distance an object moves from its rest position. Then we also have the formula that can be used to calculate the period. So the formula is period is equal to time over n. Here time is being represented as the complete of n oscillation. As we can see here, we are saying that where t is the period, this capital T, so small letter t, time to complete n oscillation, this is the one that is on top. Then n here we are saying is the number of oscillation. Then we also have a frequency is also being used. So here to calculate frequency we also use this formula, and this frequency is being given in hertz. So calculating frequency should be in hertz. Then period in seconds. So having this time should be in seconds. So now having this, let's also come up with a simple pendulum diagram to see on how we can calculate or record the movement of the pendulum. What it is here, let's say we're talking of a pendulum to say it has been hung here. There's a supporter. Let's say this is a supporter here. Yes, this is a supporter. Then there's something we'll light this is a string, it has been moved. So here we are saying this is a bulb. So we are able to see a bulb. Then this side is the movement once it has been released. Then even this side, you can also read this side, it is also the movement. So we are saying that once a bulb has been moved from this original position to this position, so now we are saying that it is able to move from point A to point B and also point C. So now to find the number of swings in here, the number of swings that a bulb is able to move from point A to point B, here we say it's 1/4. Then from point B to point C, it is also 1/4. Then again, if it's moving like this, so moving from point A to B is 1/4. Again, moving from point B to point C, it is 1/4. So when it moves from point C to point B, again it's what? 1/4. Again, from point B to point A, it is 1/4. So we are saying that when a bulb moves from point A to point C, this is what? Half. Then when it moves from point C to point A, it is also what? It will give you what? 1. It will give you 1. So here the number of swings, when you want to determine the number of swing a bulb can move from point A to point C. So a number of swings, we are saying that we just need to add 1/4. So this one we are saying that we just need to add 1 over 4 plus 1 over 4. So when you add this, we know the common denominator there, it will be 4. Then 1 plus 1, which will give us what? 2. Then we can divide there, it's 1 over 2. So we are saying that when a bulb moves from point A to point C, it's half. Then from point C to point A, it's what? 1. This is what? 1. So this is how we count the number of swings using a bulb. Let's try just like a simple example on how we can calculate this. So now this is a simple example on how we can calculate the period of the pendulum. So the question is, the diagram shows a pendulum oscillating from point A to point C and back to B in 3 seconds. So here is point A, C and back to B in 3 seconds. So this is what the time. What is its period? So having this, we know that the formula that we need to use here is what? Period, it is T is equal to small letter t over what? N, where this t is what? The time taken. Then here we need to calculate the number of what? Oscillation, which is n. So here, there we are saying that from point A to point B, it's 1 over 4. Again, from B to C, it's 1 over 4. Then C to B again is 1 over 4. So this is how we are going to calculate the number of. So we are saying that having this information, we n is equal to 1 over 4 plus 1 over 4 plus 1 over 4. So all these have got the same denominator, which is 4 here. So we say 1 there, 4 into it's 1 plus 1 plus 1. So in simple terms, we are saying that n is equal to 3 over 4. So having this n is equal to 3 over 4, which is also equal to 4 into 3, how many times? How many times can 4 go into 3? So just write it here. 4 into 3 is 0. Then 4 into 3 is 0. Point, you put 0 there. So 4 into this 30, it's 7. Then remainder 2. It's 28. Yes, remainder 2. 4 there is what? 5. So we are saying that t is equal to, where there is small letter t, which is representing time, we write 3. We write 3 over there, we write 0.75. So 0.75 into 3, how many times? So you physics calculator is being allowed, so just say 3, then over 0.75, and the answer is 4. So our period here, t is equal to 4 seconds. So this is what the answer is. So these are just 2 factors that can affect the period of the pendulum. So the period of the pendulum can only be affected by the length of the string and also acceleration due to gravity. So acceleration due to gravity can affect what? The period of the pendulum and also the length of the pendulum. Thank you. If any question, please you can comment.